Let's have some fun today with drawing the cumulative frequency curve. Here we have a set of data representing heights for students. The first column representing the heights and the second column representing the number of students, also known as our frequency. From this set of data, it is very difficult to determine the median height and the upper and lower quartile values. So to get those values, we need our cumulative frequency curve. Before drawing the curve, we need to consider two things. One, to draw our curve, we're going to be using our upper limits. For the first column here, in the first class, our first interval, 159 to 162, our upper limit is 162. And we repeat with that for the other intervals. So we have 166, 170, 174, 178, 182, and 186. Extend that there for you. And be sure you're not skipping any interval. We had 1, 2, 3, 4, 5, 6, 7. So for this one, 1, 2, 3, 4, 5, 6, 7, all accounted for. Now, remember we're drawing a cumulative frequency curve. And that means then that we're going to need the cumulative frequency. So from the given table, the number of students, which is also known as our frequency. We're not going to be plotting against that because that's frequency. We need the cumulative frequency. For the cumulative frequency, you're accumulating the data, and at the end, we'll have the total. In the first interval here, we have 1, and from there, we'll bring that forward, and we'll be adding 1 plus 4, 5. Bring that forward, 5 plus 11, 16. Bring that down again, 16 plus 12, 28. 28 plus 6, 34. 34 plus 4, 38. And finally, 38 plus 2, 40. Interesting to note is that this figure, 40, was the given total frequency in the original statement for this question. If you're not getting that total frequency, be sure to recheck your addition. Maybe you made a mistake in recording your values. Now we're going to be drawing our cumulative frequency curve. We have a given scale here for you. Using a scale of 2 centimeters to represent 5 units on the x-axis and 1 centimeter to represent 5 units on the y-axis, construct a cumulative frequency curve. We have the graph here already marked for you. But keeping the scale in mind for our x-axis. Now, if you look carefully at our upper limits, it starts from 162. It is not recommended that you start counting from 5, 10, 15, 20. In that case, you would need probably 10 graph sheets just to draw that one cumulative curve. So what we'll do is create a break in your graph in the x-axis like a lightning bolt. This signifies that the graph has been extended and a portion has been hidden for now, temporarily hidden. So let's put in our figures. We need to make arrangements to fit 162 all the way up to 186. So we'll have 160, 165, 170, 175, 180, 185, and let me squeeze in here, 190. And this axis, that represents the heights. Let me put that there in centimeters. And for our y-axis, cumulative frequency curve, we cannot be using the frequency. Remember, it's a cumulative frequency. These values go as high as 40. So be careful when you're doing this. This axis represents cumulative frequency. And to refresh our memories on the scale, for our y-axis, it says that the scale needs to be 1 centimeter for every 5 units. So we count 5, 10, 15, 20, 25, 30, 35, 40, and I'll put one more there, 45. So now we're ready to graph this curve. Now be careful, the scale might be tricky again, and ratio comes in quite handy. Just to be sure, 5, 10, 15, 20. 20 of the miniature boxes. I'll put that calculation up here for you. 20 of the boxes is equivalent to 5 units. So how many boxes would give us 1? Using ratio, 20 times 1 divided by 5, we get 4. So every 4 box, 1, 2, 3, 4 is 1. So that's 161. But remember, we need 162. 1, 2, 3, 4, 162. And we can keep doing that, but since I know that this is 162, I just need to plot that against 1. 162 to 1. Now, also for the y-axis, we need to locate 1. But if we're saying that every centimeter is 5 units, where exactly is 1? Again, if you need to, use ratio. We have 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of the boxes. I'll put that here for you if you need that. 10 of the boxes is equivalent to 5, so how many boxes is equivalent to 1? Where can we find 1? Ratio gives us or tells us that it's 2. Every 2 boxes is equivalent to 1. So if I want to plot then 162 to 1, it will then be right there. Don't make these dots huge. You have to make sure that it's at a decent size, large enough for you to see, but not too big to make a hole in your graph. Now, the second point that we need to plot then will be 162 to 5. 166 to 5. So we go back to our x-axis. Every 4 is 1. 1, 2, 3, 4. So I know that's 166, and it goes to 5. That one is easy since 5 is already there for us. We mark it. There we go. Our third coordinate, 170 to 16. This might take you some time, but it's fairly easy. We locate 170, and it's to 16. We know where 15 is. Count 2 boxes above that mark, and you'll have 16. The next point, 174 to 28. Now 174, if this is 175, and that means 174 is to the left of that. So I just need to count 4 spaces back. 1, 2, 3, 4. There we go, 174. Mark it. Mark those points. If you need to mark it with your pens or pencils, mark it so you don't miss it. So 174 to 28. I locate 20 on my graph. Here is 20, 25, but remember it's 28. And there is 30. I can start counting from 25 upwards, or I can count downwards from 30. So I'm going to count downwards since I believe this is quicker for you to grasp, but I'm not going to count 2 spaces, but rather 4. 1, 2, 3, 4. So 174. Oh, sorry, it will be here. I went at 175 if you notice. It is tedious. If you need your glasses, you might need to take those out. So 174 to 28. So let me put an X on that one since I'm using pens. And the other point then, 178 to 34. Okay, now this one, let me mark the points here at the bottom. That's 176. 177, 178. So I have it. I need 34. 178 to 34, I locate 35 here. So I just need to count again. You just need to make sure your pens or pencils follow along that line to 34. So there's 35, I count 2 spaces down. Let me just make sure I'm on the right line here. Okay, so we have that. Almost done. We have 182 to 38, that's our next point. Let me mark that here. 1, 2, 3, 4. Is that right? Yes. 1, 2, 3, 4. 182 to 38. So it's getting trickier, but not that difficult, as long as you have some patience. Here's 140 no, that's 40, but it needs to be at 38. So I'm going to count 4 spaces below that line. 1, 2, 3, 4. Yep, I believe that's it. And the final point that we're going to plot is 186 to 40. I believe that one is probably one of the easiest ones for us to see. 186 to 40. There we go. It comes with practice to develop that steady hand. And sometimes it's difficult to get it totally smooth, but we understand it's free-handedly drawn. But there we have it, our cumulative frequency curve. Now, this curve can be used to do several things. Remember, at the beginning, we wanted to find the median and the upper and lower quartile values. Now, let me bring those questions here for you. The median height. Notice we're not asking for the median class, the median height. Median means middle. And to find the middle, that's exactly half of any data. So let's first find the position. It's the half nth term. N. N is the total frequency. And for us, that frequency is 40, so half of 40 is 20. The 20th term is our median height. Remember, this cannot be given or gotten from your table because we have no idea of exactly. The 20th term would fall somewhere in this class, but it's hard. We need to go back then. Let me bring the cumulative frequency table here. The 20th term, let me use my red pens for you. This stops at 16, so the 20th term will lie somewhere here around this area, but we're not sure. So to be specific, to be exactly sure, we'll get the 20th term from our graph. Let me bring that back. The 20th term is our median value. So we locate 20 on our cumulative frequency axis, your y-axis, there we go. And using your ruler and your pencils, or pens, you draw a straight line. I'm going to use a solid line just so you can see clearly. And this is the median line for us. I'm going to label that. That line is drawn until it reaches your curve. Once it reaches your curve, you're going to draw now a vertical line coming down to your x-axis because we're looking for the median height. So I'll put that in there for you, making sure this is as accurate as possible. Now, I want to take you back to the instructions here. It says using your graph, not your neighbor's graph. It has to be your graph because remember, it's not totally accurate. We're not computers, so you have to make sure this is being read from your graph that you draw. So now we need to determine the exact median height. Now, remember also that every 4 space is considered 1 unit. So I have here 170, 171, and 172. Our median height then is approximately 171 171.2. And that's it. We calculate half in term, half of 40, 20. You go to your curve starting from your frequency, cumulative frequency axis. You draw that straight line until you reach the curve, and then you make a right angle, turning down to your x-axis, and then you read that position there. And for us, it's approximately 171.2 centimeters. Now, from here, you can also see, using your graph, we can determine the upper quartile value. The upper quartile value also takes a location, and the upper quartile is in the upper half of the data, so we use 3/4. It's a 3/4 nth term. It's a ranking again. So that means 3/4 of 40. So 3/4 of 40 happens to be the 30th term. And to get the 30th term, we'll bring back our graph for you, and we need to locate that on our graph. The 30th term, for the y-axis again, the 30th term, we've located 30. Using your rulers, you draw that line. Again, I'm going to use a solid line. And I'm going to label that line the upper quartile. It's good to label it so that you have something to go back and review from. So, and it touches my curve at approximately here, so I'm going to draw my line. All right, again, try to be as accurate as possible, but again, we always make allowance for human errors. Now, we can clearly see where our upper quartile value lies. It's approximately 175, let me put that in red for you, 0.2. So 175.2 centimeters happens to be our upper quartile value when it comes to this graph. The next value we want to calculate is our lower quartile value. And this one happens to take the shape 1/4 nth term. So 1/4 of the total frequency, 1/4 of 40 gives us 10. So it's a 10th term is our lower quartile value. Going back to our graph, the 10th term, locate 10, cumulative frequency, we have it there. And using our rulers again, we draw that line, a solid line again to help you. And label that lower quartile. It touches my graph at this point here, so I'm going to draw a line, making sure this is as accurate as possible. And now I need to know what that point is to get, so that I can have our lower quartile value. So let us see what that might be. So I'm marking it, 1, 2, 3, 4. Okay, this one is fairly easy. 165, 166, 167, 168. Lucky for us, we don't have a decimal value, but if you get a decimal value, that's quite okay. So it's 168 centimeters. So just to recap on that, our upper quartile value takes the position or ranking 3/4 nth term. 3/4 of your frequency, 40, gives us the 30th term. So on your curve, locate the 30th term, draw that line until you reach that curve, and then you go down, vertical line, to your x-axis, and you read the location. For us, it happens to be 175.2 cm. And then for the lower quartile value, where that one takes the position ranking 1/4 nth term, so 1/4 of 40, that's your 10th term. And the 10th term then, from the graph, the 10th term, you read that, drawing your line to your curve and downwards, gives us approximately 168 centimeters. Moving on to our fourth question, hence evaluate the interquartile range. This is the difference between the upper quartile value and the lower quartile value. It's already marked here for you. The upper quartile value is 175.2, while the lower quartile value is 168. The difference gives 7.2, so our interquartile range is 7.2 centimeters. The final question, evaluate the semi-interquartile range. Semi means half, so that means the interquartile range divided by 2. Therefore, 7.2 centimeters divided by 2, giving us 3.6 centimeters as our semi-interquartile range value. This brings us to the end of our lesson for the cumulative frequency curve. Be sure to check at the end of this video for additional practice questions.